Thank you, Stefan. Thank you so much for the introduction and good afternoon to one and all present here. I would be talking about optimizing distribution efficiency and reducing operational waste using Bayesian network model, right? And before I begin, let me quickly give a short note about myself. I'm Anand Wilson, and I work as a senior data science consultant in the advanced analytics and applied AI team at C5I. My background is in applied statistics, and I bring over 12 years of experience in AI and data science. I focus on knowledge modeling, machine learning using BayesiaLab, and I am especially passionate about machine reasoning, causal inference, and experimental design. So that's a short about myself and getting back to the topic. So why this topic today? Because we encounter a lot of CPG, consumer product goods problems, where wastage is a big problem, right? Because it's a day to day usage commodity, and there are a lot of aspects that goes with this particular domain. So hence we wanted to see what are the different traditional methods that is used to solve this problem, and how we can utilize the Bayesian network model, and also to look at the generative artificial intelligence with respect to the Bayesian network models also, which will give a lot of added value to this business problem, right? So I would be covering, what is the background to this problem and how we are approaching this problem. Uh, I've also prepared and shortlisted the kind of data that we are using and how, in different ways, we are preparing the same. The different models that we have utilized from BayesiaLab include the unsupervised network, the supervised networks, and then finally we are attempting Helixia, the dimension elicitor, which is not completed, still work in progress, but I would like to speak and I would like to elaborate how we are approaching it from that angle. Yeah. So a quick background to the problem here. There is a lot of rising absolute, or rather, a lot of wastage that happens in the specific CPG industry, right? Due to various factors, like there are delivery delays, there are transportation problems, and there is shelf life, stocking, inventory problems, and on top of this, there are a lot of fraudulent activities or anomalous behavior from the distributor, from the parties that is involved in the transportation at the store. And these data or informations are very sparse, and signals are also very, very interdependent, right? So which means we cannot isolate them and study them separately. They are all connected together. So our objective was to build an unsupervised patient network, refined with the expert priors, because we have a lot of domain knowledge coming in this area from the business, the which we can consume, but not necessary that that is all translated into the data. So we can get those information and pass that on to our network to iterate and get to a diagnostic and early warning system that also supports what are the different what if simulations we can do, right? Now, quickly looking at the value that it generates, it is very faster time to insight, without, I will not say it is not exhaustive. It is to an extent exhaustive, because the kind of iterations that we do, the level at which we go in. But comparing to the other traditional techniques, what we have seen is this is more result generating in a shorter span of time. And this also gives a lot of actionable levers and measurable reduction in wastage and the delays associated with this wastage. Now, the most interesting part or the most value creation here is the utilization of domain expertise, like I said, through the causal priors, which actually guides the learning process towards the most relevant variables and directions. Let me quickly go through the problem statement which you have identified. So whenever we use the regular descriptive and traditional analytics, right, that do not effectively identify the factors which needs to be controlled or tested to experiment the reduction in wastage, right? So when I say that there are a lot of factors, but it may not be measurable to an extent where that can be controlled, and then you can see the relative impact. So this happens majorly because of the limited uh, connections between the data, which we can establish using Bayesian network models. And there are a lot of partners and geographies and time windows, all these kind of aspects, which is a little difficult to tie it together, right? Or if you analyze this in silos, we may not get a, one type solutions which can work and, collectively and effectively work, help us in reducing the wastage. So the practical fit that we identified was in this particular scenario is we have a lot of mixed data types, which has missing. It has a lot of hidden structures. And finally, we can utilize it to explain the relationship fit in the complex logistics environment. So to keep it simple, our goal is earlier detection and a clearer driver attribution to targeted investigations. Now, data, I've not listed all of it, but these are the major, data and the KPIs that we have used, like all information with respect to partners and distributors, the different routes, geography related aspects, the delivery time frames, the different sales with respect to um, the sales that happens at different levels, then inventory aging, shelf life, distributor efficiency, and wastage outcomes are some of them to mention, right? Uh, so how we did this, we analyzed data from multiple sources, and we wanted to ensure that we are extracting meaningful insights from the data before we actually plug in it into this particular system, right? And we also had to put a lot of efforts in determining the optimal level of aggregation for modeling based on data patterns and insight. This is why, because when though wastage is a main problem, all the data that is associated with that could be at different levels, right? So for example, some could be at a weekly level, some could be at a monthly level, and some could be at a daily level. So now it's a decision that you need to make, at what level you want to consume, because um, maybe the next slide will explain this a little more in detail. Uh, One second. Yeah. So we always get this question, right? There is abundance of data, and sometimes the data is scarce, right? Whenever there is a lot of data, why is it not enough to rely on descriptive a lot, right? Descriptives gives a lot of information. You can do a drill down, right? But one problem that we identified is you have a lot of data. It is not framed or structured in the right way, and we are not approaching it with the right ML technique, right? In order to get to the final insight. So it's a combination of descriptive, it's a combination of ML, and then we get to the final insights by deriving whatever we are finding from an ML, right? So to keep it short, descriptives are like, it tells us what is visible. ML tells us what is real. So because we are testing it, right, in an ML, whether it's real or not. And together, descriptive and ML reveal what matters so that we can, take impactful decisions. Right. So so we have a lot of data. So the underlying problem is we have a lot of data. We have to prepare it in such a way that it gives us the right directions. And we are also looking at the right factors, be that will be very impactful to solve our business problem. Okay. So we can start with descriptive, we can get into the ML modeling, and from the ML model, we can get to a final insight, which will be again applied back to the raw data or the descriptives. So now, instead of searching in a very vast area, so descriptive is like a very vast area. ML model help us to fine tune or look at a specific spot, right? And then when you know that this is the specific area that you need to investigate, you can go back to the data and find it very soon, right? So this is how we can have targeted investigation. We can save our time, and we can have faster results that are more actionable. So we started with the network, which is an unsupervised. we wanted to study, what are the different factors that is associated with wastages, right? So we have geography as a component, return as a component. We also brought in Overstock, sales price, and distributor fraud score. So, for example, distributor fraud score is a combination of a lot of factors. We wanted to combine it and bring it as an aspect to see that how that is connected and how that is bringing value in this network, right? Now, returns is obviously is having the highest note force, and and it might also sound that this is too obvious that when you have more returns of the certain goods, it will naturally lead to more wastage. But we wanted to study what is associated with returns, how different things are connected together. If we directly use wastage and keep returned outside, we might not be capturing some of the very important relationship in the structure. Uh, and we also wanted to study, how the distributed fraud score correlates with return. So that's an indication that what is the channel through which it operates, how that is coming together. So this is a very initial network. We have seen certain things here, but the upcoming networks will tell us when we do further investigation what needs to be looked more and how we can go more deeper into this network analysis. So some more observations to point out, it is with respect to wastage, how that connects to returns, and the price elements, price movements with both demand and inventory. So that's another area that needs further investigation, right? So there is a demand, there is a the different price elastic elements that we need to study. So that this tells us how important it is and what more we need to look from this variable perspective. Then we also have geography related aspects, like I said. And, regional dynamics are also very important with respect to return, wastage, distributed fraud score, because, um, you know, region is very, very dynamic. And, we often see that a lot of these things is tied back to a particular region, and every region has its own behavior coming up, which is also we are studying in detail in the upcoming study. So the first level model, which is the unsupervised model, gives us a lot of indication. It gives us a lot of understanding without we bringing any bias into it, without we bringing any conditioning into it. Now that helps us, where we should look at and what we should look at more in detail, right? So return, though it's an obvious thing, we still need more prioritized or focused interventions with respect to waste and return. We need to segment it by geography and study it further, right? And we should also look at any of the price balancing actions that we need to take in order to control for the wastage. So these were some of the preliminary insights and the next steps from an unsupervised model. Now, getting into a supervised network model, and the important aspect here is now we get to see what is connected and what is driving, or what are the different contributions that is coming and the different synergies we can observe, right? So distributed fraud score and geography is coming up with good contributions, which is telling that um, you know we, when we know that distribution fraud score or anomalous behavior from the distribution is an important factor. Now, we knowing that in certain regions you have to take actions region specific, because there is a connection and there is an association, and all your strategies needs to be specific to a region, because this is a region specific thing, right? One policy that is applied in a region may not work exactly the same in another region, because the factors in that region that there could be different aspects which we can study further, right? So that's one aspect. So geography, fraud score, geography, return. So there are different combinations that is coming up very evidently, and it also tells us, where we should, put our targeted investigations into. Some of the other synergies that we observed using this was distributed fraud score, overstock synergy, price return synergies, and geography and sales. So we can definitely analyze what are the different combinations, which combination is more important, and where we should put our targeted investigations in. Now, this is one of the important factor. So we have a lot of variables. we fine tune the data to get to an aggregated level of data. So for example, uh, fraud score for distributors is based on a lot of factors, right? How they do a lot of things. They might be uh, returning a lot of products which they which is actually not wasted, or there is still time to it and they may not want to sell it, or they might be using some of the allowances policies, a lot of elements, right, where they want to make some do some fraud activities, or they are showcasing anomalous behavior there. Now all of that is considered into the model. Now we have learned the model both unsupervised and supervised, but still the story is not complete. There is a lot of other factors that can still influence the study. So whenever we approach this problem, it is very common that we don't have all the variables which has to be studied in order to come up with an optimal solution. So uh, we found this is a very interesting application that we can use, uh, n- so that we know that certain things are very common here. Right. One second. We know that there are certain variables that is a must to have in the system, but unfortunately or fortunately we would not have captured. So that is where this generative artificial intelligence comes into play, and we can make use of helixia, right? And some of the variables that we have identified is like demand planning elements, right? This has a key role because from any manufacturer point of view, demand planning is crucial because it will have a lot of elements like forecast bias. You need to maintain your safety stock, right? There are different policies in which you need to, make it. Then there is a service target, right? And replenishment cadence. All these things you need to understand. So you will have to see that how these elements play together, and bringing this element of demand planning into a network, how that will have an impact, right? Second is production forecast. Same as demand planning, production forecast is an important thing from a manufacturer point of view because you have to maintain your stock levels. You have to look at different risk flags. Then you have to look at the demand that is coming from the market and accordingly do it. Uh, then there are store elements also. Now all the products goes into a store. There are different kinds of stores. Some are chain stores, some are cash stores. So all these stores will have different policies, and they have different way of stocking things, and they have different way of dealing with distributors and all that, right? So footprint, there are a lot of aspects that we can cover specific to stores, right? And finally, the promotional activities, that also is a very important thing. You want to give away a lot of things. You want to sell a lot of things on discount. So you want to, produce it more, and naturally that will lead to wastage. So um, what we are doing here is we are, creating all these variables. We are getting the information around it, and then we are testing it with all the existing variables to see that how we identified or how we quantified the available variables in the right manner. And then we want to see that how different this will be in the presence of this variable, which is not there in the data, but we get to an understanding, right? How these factors can potentially impact, and in a way that we are rightly quantifying for this, which is not available otherwise, right? So I just wanted to say that how this becomes like using your prior knowledge. So this is also coming from prior, right? From the domain expertise, that these variables are very important and they play a very crucial role. So utilizing the benefits of Bayesian network modeling, which gives the interaction effect and the combination effect, the different contributions, the synergies that you see, the different iterations you run in order to test various situations and scenarios, and then adding these variables, right, which is actually not in the data, but we know that these are very, very important elements that play a key role in deciding your wastage. uh, just to highlight, some of the testings that we do, whether promotions, how that will impact sale, overstock, forecasting error, how that will impact the different aspects of overstock wastage, right? And demand planning policy, store attributes, promotions, these are the different conditions that we would like to test it over here. Yeah. So that was a quick and short presentation. Um, Any questions, any suggestions? I would like to hear it from the experts here.